Hello everyone, this is Sir Marvin Bartido. So for our lesson for today, we're going to discuss field compaction tests. No, so we're going to recall here the specification for field compaction. We're going to discuss yung mga compaction test methods na ginagamit natin to determine the field unit weight of compaction. So we're going to discuss yung sand cone method, rubber balloon method, nuclear method, and we're going to solve sample problems here. Alright, so let's recall the specification for field compaction. So class, yung specification na kailangan natin dito is yung relative compaction. So class, yung percentage na required ng relative compaction class, nakadepende yan. Okay, but usually class, yung percentage niyan ay nagre-range from 90 to 95%. Okay, so para makuha natin class yung relative compaction, yan ay equal sa gamma dry field over gamma dry max lab times 100. Okay, wherein itong gamma dry max lab class, ito yung maximum dry unit weight ng soil natin na yan class ay dinetermine natin from laboratory compaction test methods. So yung mga laboratory compaction test methods, yan class ay standard Proctor test o kaya modified Proctor test. No, so yan class ay na-discuss na natin sa previous discussion natin. Okay, yung pagkuha natin nung gamma dry max lab. Ngayon class, itong gamma dry field, yan naman class yung dry unit weight ng soil doon sa field natin after compaction. No, so para malaman natin yan class, gagamit tayo class ng mga field compaction tests. No, so for this discussion class, yan yung pag-uusapan natin kung ano yung mga ginagawa natin na field compaction test, okay, para ma-determine natin yung field unit weight of compaction ng soil natin. Okay, so yung mga standard procedures class for determining the field unit weight ng compaction ng soil natin include, ito class, yung una is yung sand cone method, ikalawa is yung rubber balloon method, and the third one is yung nuclear method. So, i-discuss natin itong mga methods na ito, no, dito sa discussion natin. Okay, so, let's start our discussion for this. Alright, so we will start with the sand cone method. So class, dito sa sand cone method, we are going to use a sand cone device which consists of a glass or plastic jar with a metal cone attached at its top. Okay, so class, ito yung itsura ng sand cone device na ginagamit natin dito sa sand cone method. Okay, so ito class yung glass or plastic jar na binabanggit dito. So, ito yon yung glass or plastic jar. And then, yung naka-attach na metal cone sa top niya, ito yon. Okay, so class, may mapapansin ka rin dito na laman ng jar. No, so, this is a soil. No, itong laman ng jar na ito, yan class ay Ottawa sand specifically. So, yan class ay buhangin. So, later on class, no, i-explain ko kung para saan yan, yung buhangin na yan, no, kung saan natin yan gagamitin dito sa experiment natin. Okay, so class, dito sa sand cone method, di ba nga, primarily, ang kukunin natin dito class is yung dry unit weight nung soil natin dun sa field na na-compact. Okay, so class, katulad lang din nung formula natin, no, sa pag-compute ng dry unit weight, which is weight ng soil solid over total volume. No, so yun yung mga kailangan natin class na makuha dito sa test method na to. So again, we need to determine yung weight ng soil solid at saka yung total volume para ma-compute natin class yung dry unit weight, no, na kailangan natin. Okay, so we will start dun sa pag-determine ng weight ng soil solid. Okay, so class, di ba yung weight ng soil solid, equivalent din siya dun sa weight ng dry soil, no? So, para malaman natin yun class, in the field, we are going to excavate a small hole or maghuhukay tayo, no, ng small hole in the area kung saan yung soil is na compact. Kung saan natin i-check class kung yung compaction, kung okay na ba. No, so maghuhukay tayo doon class, and then yung ma-excavate class na soil, no, i-determine natin doon class yung weight ng moist soil. So yung ma-excavate kasi natin na yon, no, yun class ay moist soil. No, moist soil yon. So, titimbangin natin yon para malaman yung weight, and yung magiging notation ng weight natin doon ay W sub 2. Ngayon, from that same soil na na-excavate, kailangan din natin class alamin yung moisture content nun. Okay, so kung paano natin class inaalam yung moisture content? Diba? So, inaalam lang natin yung mass or weight ng moist soil Tama? Tapos, i-oven dry. Tapos, aalamin yung mass ng dry soil over mass ng dry soil lang yun. That's just how we determine moisture content. And then, after nun class, after nating malaman yung weight ng moist soil or mass, at saka yung moisture content, no, pwede natin class malaman yung dry weight ng soil, no, by this formula. So, ito class ay W sub 3 is equal to W sub 2 over 1 plus W. So, ito, lowercase ito ha, and this is in percent over 100. So, actually itong W sub 3 na to, ito yung dry weight ng soil. And then, ito namang W sub 2, yan class yung moist weight ng soil natin. And then, itong W na to is yung water content. So, actually, itong formula na to class, galing lang din siya dun sa gamma dry is equal to gamma over 1 plus W. Kung naalala mo yon dun sa mga basic formulas natin. Gamma dry is equal to gamma over 1 plus W. Tama? So, yung gamma dry, di ba, yun class IWS over V or weight ng soil solid over V. Tapos, ito namang gamma, yung moist unit weight, yun IW over V. Tama? So, class, yung V na yan, okay, so, yan ay parehong total volume, tama? So, ibig sabihin, pwede natin yan makancel. So, itong WS, yung weight nung soil solid natin, yan class ay equal din sa weight ng dry soil, which is ito yon yung W sub 3. And then, ito namang W, yan class ay weight nung moist soil, which is ito yon yung W sub 2 nga. And then, yung W, yan yung water content. So, naka-divide lang to sa 100 kasi naka-percentage nga ito, yung water content dito, no? Okay. So, class, ganun natin dinedetermine ha yung weight nung dry soil or nung soil solid. Okay, which is kailangan natin yon. Ngayon, class, ang isa pa natin kailangan malaman is yung total volume. No, so, kailangan natin, class, ma-determine yung total volume nung na-excavate natin na soil para malaman natin, class, yung dry unit weight. Okay, so proceed tayo. Alright, so for us to determine the volume that we need para dun sa computation ng dry unit weight natin, no, ito yung mga kailangan natin gawin. No, so meron tayo class jar na merong uniform dry Ottawa sand. So ito nga yun, yung jar na yon. Ayan, tas yan yung Ottawa sand. And then, what we're going to do, kailangan nating malaman class yung combined weight nung jar, nito, nung cone, at saka nung sand, nitong Ottawa sand. So titimbangin yan and i-record yun class. No, yan class IW sub 1. And then after nun class, what we're going to do, dun sa excavation or dun sa in-excavate natin na small hole, no, previously, no, what we're going to do is itong sand cone device na to class, i-invert natin yan class and ipe-place natin yan class dun sa hole, no, dun sa butas, dun sa hinukay natin kanina. Ayan, so ito class yung hole, tapos class ito yung sand cone device natin. So, in-invert natin yan. No? So, what we're going to do, class, is i-allow natin na yung sand from the jar, mag-flow out siya papunta dito dito sa hole at saka dito sa cone. No? So, kapag class na puno na, no, yung itong hole, no, itong butas at saka itong cone, so magi-stop na yan magi-stop na yan na mag-flow out from the jar. No, so, class, by that time na mapuno itong cone at saka itong butas, itong hinukay natin, class, no, so, we are going to determine yung combined weight nung jar, nung cone, at saka, class, nung remaining sand na nandito sa jar. Okay, so ulitin ko, kailangan nating malaman yung combined weight nitong jar, nitong cone, at saka nung sand na nag-remain dito sa jar. No? So, yun yung kailangan nating malaman. Ha? So, yan class ay i-record natin as W sub 4. No? So, yung mangyayari class, yung kailangan nating malaman dito is yung W sub 5. So, yung W sub 5 class, yan yung weight nung sand to fill the hole and cone. So, yan class yung weight niya. Nung weight nung sand na nandito sa hole at saka nandito sa cone. So, aalamin natin yun class. So, para malaman natin yun class ay W sub 1 minus W sub 4. So, class, itong W sub 1, ito yon yung nauna nating na-record na, ito, yung buong timbang nito. No? So, kapag sinubtract natin dyan yung W sub 4, which is yung, ano lang yan, combined weight nitong jar, nitong cone, at saka nitong natirang Ottawa sand dito sa jar. So, yung makukuha natin, class, is yung weight nitong sand sa cone at saka sa hole. No? So, after nun, class, so ituloy natin. Alright, so class, para malaman natin yung volume ng excavated hole, which is yun yung kailangan natin sa computation. Okay, so gagamitin natin class yung dry unit weight nung Ottawa sand. So class, yung dry unit weight nung Ottawa sand, it is known. No, kaya nga yun din yung ginamit natin no dito kasi known yung gamma dry niya. Ngayon, yung formula ng gamma dry, 'di ba, ay weight nung soil solid over the total volume. Itong weight nung soil solid nung Ottawa sand, so yan ay madedetermine din natin, no, yung weight nung soil solid na yan class, yan lang yung weight nung Ottawa sand, okay, na nag-fill dito sa hole natin, dito sa butas natin. Tapos itong total volume na ito class, yan yung volume nung Ottawa sand na nag-fill nga doon sa hole natin. Ngayon, yung volume na yan ng Ottawa sand, equal yan doon sa volume nitong excavated hole, and yung volume ng excavated hole na yan, equal yan dun sa volume ng soil na in-excavate natin. Yun yung kailangan natin, di ba? Yung volume na yon. So, we can determine this volume class by this formula. So, yung W sub 5 natin, ito class yung weight nung sand natin dito sa hole at saka sa cone. So, kailangan nating ibawas dyan yung weight nung sand dito sa cone. So, ito yung class yung W sub C. No? So, itong W sub 5 minus W sub C, ito yung weight ng sand na nandito lang sa hole. Okay? And then, yung gamma dry nga ng sand na to class, yan yung known or given na dry unit weight ng Ottawa sand. So, itong volume na to, ulitin ko ulit, ito class yung volume ng Ottawa sand na nag-fill dito sa hole. And yung volume na yan ng sand na nag-fill sa hole, yan class ay equivalent dun sa volume ng hole. No, ngayon, yung volume ng hole na yan, equivalent din yan dun sa volume ng soil na in-excavate natin, which is yun yung kailangan nga natin. Okay, so, class, by the way, itong W sub C at saka yung gamma dry nung Ottawa sand natin, yan ay determined from the calibration done in the laboratory. So, mga known yan, mga given yan. Okay, so, after nating malaman itong volume na ito, class, okay, so pwede na natin class malaman yung dry unit weight ng compaction made in the field. No, so ito class yon, yan ay equal sa W3 or sub 3 over V, wherein itong W sub 3, yan yung dry weight ng soil excavated from the hole na yan yung pinakauna nating ginawa. And then itong total volume na to class is ito, yung nakuha natin dito. Okay, so that's how we determine class, yung dry unit weight nung soil natin sa field after compaction using sand cone test. Okay. Alright, for the second method that we can use to determine the dry unit weight of the compacted soil in the field, this is rubber balloon method. Okay, so class, for rubber balloon method, we are going to use a calibrated vessel as shown here. So ito class ay calibrated vessel, okay, na merong rubber balloon, no, dito sa bandang ibaba niya, merong rubber balloon dyan class, na kapag pinump ito, no, so yung tubig na laman niya class ay mape-pressure para bumaba class yung rubber balloon. No, so ito class no yung kumbaga device na ginagamit natin dito for rubber balloon method. Okay. So class for rubber balloon method, no, katulad nung sand cone method, kailangan natin ma-determine yung weight ng soil solid or weight ng dry soil over yung total volume. Okay, so sa pagkuha natin class nung weight ng soil solid or weight ng dry soil, it's just the same kung paano natin kinukuha yon using sand cone method. No, so yung naguhukay lang din tayo class ng small hole, and then yung excavated soil doon, okay, we're going to determine yung weight ng moist soil na yon, and i-determine din natin yung moisture content. And then from the recorded weight ng moist soil at saka water content, okay, so we can use yung formula natin to determine the weight of the dry soil or weight nung kumbaga nung soil solid natin, which is equal to the moist weight over 1 plus water content. Tama? So, plus after nating ma-determine yung weight nung soil solid, okay, so para dun sa volume class nung soil na yun class, no, kailangan natin yun ma-determine using this device. So, what we're going to do class is before excavation, dun sa area kung saan tayo mag-excavate class, no, una natin gagawin class is we're going to place this vessel, calibrated vessel doon sa area na yon kung saan tayo maghuhukay. And then what we're going to do, class, is ipapump natin ito, class. No? And then kapag pinump natin to, yung water na laman nito, class, ay mape-pressure para bumaba. So what happens is that bababa din, class, yung rubber balloon. No? So may stretch yon yung rubber balloon pababa. So class, initially, no, ground pa lang yan, hindi pa tayo nag-excavate. So class, kapag pinump natin ito, bababa yung rubber balloon. So hanggang sa matouch na, class, yung ground kung saan tayo mag-excavate. No, so kapag na-touch niya na yan, kapag na-touch niya na completely yung ground, class, hindi na natin to mapapump. So by the time na hindi na natin to mapapump, class, so we are going, class, to record, no, yung reading ngayon dito nung tubig. So medyo nabawasan na yan kasi medyo bumaba na yung rubber balloon dito, class, no, na-touch niya na yung ground. Okay, so i-record natin, class, yung reading as the initial reading. So kailangan natin yun, yung initial reading. And after nun, class, we are going to excavate na yung, kumbaga, yung area na gusto natin i-excavate. Okay, so i-excavate yun, and after siyang ma-excavate, we are going to place again this calibrated vessel over the hole. No? So, yung gagawin natin, class, is ipapump ulit ito. And then as we pump this, no, yung tubig ay mape-pressure at yung rubber balloon, class, ay bababa. Okay, so class, ipapump natin ito hanggang yung rubber balloon natin completely ma-fill niya yung hole. Okay, so once na completely ma-fill niya na yung hole, class, hindi na natin ito mapapump. Okay, so by that time, class, i-record na natin, class, yung magiging reading dito sa parang ano kasi ito, class, para tong graduated cylinder na may mga reading. So i-record natin ngayon, class, yung magiging reading ng water. So we will record that as the final, no, as the final volume. Ngayon, class, yung initial volume na nakuha natin, isosubtract natin doon yung final volume. And then yung magiging sagot doon, class, is yung volume na kailangan natin. So yun yung volume ng rubber balloon filled with water na to completely fill, no, the hole. So yung same volume na yun, class, okay, yun yung volume ng hole, and yung same volume ng hole na yun, yun din yung volume nung soil na in-excavate natin doon. Okay, so kapag na-determine na natin, class, yung volume na yun, class, edi pwede na natin, class, ma-compute yung dry unit weight nung soil na yun na in-excavate natin. So yung W sub 3, yan lang yung dry weight of the soil excavated from the hole. And then itong V naman, yan yung volume ng hole. Okay, so that's how we determine here, class, ha, yung volume. Okay? Okay. Alright, for the third and last method, ito, class, ay nuclear method. So for nuclear method, class, gumagamit tayo ng nuclear density meters. Ito yun, class, yung itsura ng nuclear density meter. So ito, class, ay gumagamit ng radiation para ma-determine yung compacted dry unit weight ng soil. No? So class, ito ay maganda na gamitin, no? Kasi, class, mabilis na nalalaman dito or nakakalculate yung kailangan natin na dry unit weight ng soil. However, class, hindi siya masyadong ginagamit sa Pilipinas kasi mahal siya. Okay, so aside sa mahal siya, since gumagamit nga kasi siya, class, ng radiation, medyo delikado siya. No, so yung mga tao, class, na pwedeng mag-operate nito is kailangan sumailalim sa proper training and kailangan may certification sila na yun nga, they are allowed na i-operate ito, no? Okay, so class, hindi na natin ito masyadong i-discuss ng detalyado, no? Pero class, itong device na ito, itong instrument na to, yung ginagawa niya is that minimeasure niya, class, yung weight ng wet soil per unit volume and also yung weight ng water present in a unit volume ng soil. Okay, so para ma-determine dito, class, yung dry unit weight ng compacted soil, no, sinusubtract lang yung weight ng water doon sa moist weight ng soil, no, per unit volume, and from that, yun na, madedetermine na yung dry unit weight, no. So that's how we determine, class, no, yung dry unit weight using this method. So hindi natin to masyado i-detalye kasi nga hindi naman din natin talaga masyadong ginagamit ito dito sa Pilipinas. Okay. Alright, let's start solving sample problems here. For sample problem number 1, laboratory compaction test results for a clay silt are given in the following table. So ito, class, yung yung data no, from the laboratory compaction test na kinonduct for a clay silt. No, so given dito class yung moisture content at saka yung corresponding na dry unit weight. Okay, and then we also have here, following are the results of a field unit weight determination test performed on the same soil by means of the sand cone method. So meron tayong given dito na calibrated dry density of Ottawa sand, which is 1,570 kilogram per meter cube. And then we also have calibrated mass of Ottawa sand to fill the cone, 0.545 kilogram. Meron din tayong mass nung jar plus cone plus sand before use. Ito ay 7.59 kg. Mass of jar plus cone plus sand after use. Ito ay 4.78 kg. And then we have mass of moist soil from the hole, which is 3.007 kg. And then we also have moisture content nung moist soil, which is 10.2%. Okay, so from this data class, now we are going to determine the dry unit weight of compaction in the field and then the relative compaction in the field. So for letter A, no, to determine the dry unit weight of compaction in the field, so ito class yung data na gagamitin natin ha. So ito yung data para sa field compaction, no, field compaction test. Okay, so ito naman yung sa laboratory compaction test, no? So ito yung kailangan natin for letter A. Okay, so class, binanggit dito sa problem na yung ginamit na method class ay sand cone method ha. So yung kailangan natin dito class ha para ma-compute yung dry unit weight is yung weight nung dry soil or weight nung soil solid over the total volume. So sa pagkuha nung weight nung dry soil, okay, so ito yung class yung W sub 3. So yan yung dry weight nung soil excavated from the hole ha. And then yung volume, which is the volume nung total volume nung soil natin na in-excavate from the hole. So, equivalent din yan dun sa volume nung hole. Okay, so, class dito, para dito sa W sub 3, ito ay ano lang ha, dry weight nung soil natin. So, pwede natin ito class ma-determine by this formula. So, ito yung dry weight, and then yung W sub 2 na to, ito yung moist weight, tama, and then yung maliit na W, yan yung water content. So, for the moist weight, class, meron tayo actually given na mass nung moist soil from hole. No? So, yan class ay 3.007 kg. So, we need to convert this class ha into kilonewton since dry unit weight yung kailangan natin ha. Okay, so i-convert natin ito class, yung 3.007 kg by multiplying it by 9.81. Okay, so yung magiging sagot dito class is in Newton. Ito ay 29.499 Newton. So convert lang natin to kilonewton, divide mo lang by 1,000. So this will become 0.029499 kilonewton. Okay, now, ito na class yung W sub 2 na kailangan natin dito sa formula. And then yung water content given naman 10.2. So substitute lang natin mga values. So, yung weight nung dry soil natin ay equal sa 0.029499 kilonewton over 1 plus yung water content which is 10.2. So, since in percent yung nilagay natin dito, divide natin by 100. So, yung lalabas dito class ay, ayan, pindutin mo class sa calculator. Yan class ay 0.026769 kilonewton. Okay, so yan na class yung kailangan natin para dito na W sub 3. Ngayon, kailangan din natin class yung total volume na to. So, para makuha natin itong total volume na to, which is the volume or total volume nung in-excavate na soil, which is also equal dun sa volume nung hole. So, pwede natin yan ma-determine class by determining the volume nung sand na nag-fill doon sa hole. No, yung volume nung Ottawa, kasi Ottawa sand yung ginagamit natin dito sa sand cone method. So, para ma-determine class yung volume nung Ottawa sand na yon that filled the hole, no, gagamitin natin ito class, yung dry unit weight nung sand. So, yan ay equal sa weight nung sand, no, nung weight nung soil solid nung sand over the total volume nung sand. Okay, so dito class given yung dry density nung sand na ginamit which is 1,570 kg per meter cube. So, i-convert natin yan ha into dry unit weight. Okay, ngayon class, ito yung kailangan natin ha, itong volume na to. So, inilagay na natin to dito. No, yan yung kailangan natin. And then, para dito class sa tawag dito, weight nung soil solid nung sand, no? from this method class, no, madedetermine natin yan class, no, from the given, meron tayo dito class na mass nung jar plus cone plus sand before use. So ito, wala pang bawas ito, yung sand na nasa jar. And then meron din tayong mass of jar plus cone plus sand dito. Okay, so ito ay after use. So ibig sabihin class, nabawasan na yung sand dito sa jar, no? So napunta na doon class sa hole at saka doon sa cone. No, so class kapag sinubtract natin ito, no, yung mass nung jar plus cone plus sand before use at saka yung mass niya after use, okay, yan ay 7.59 kg minus 4.78 kg. Class, yung makukuha nating sagot dyan is yung mass nung sand, no, na nag-fill dun sa hole at saka dun sa cone. Okay, so remember that ha. Okay, so yung 7.59 minus 4.78 kg, so yung makukuha natin dyan is yung mass nung sand na nag-fill dun sa hole at saka dun sa cone. Okay, and then i-multiply natin ito class by 9.81 para maging weight, no? So, yung magiging sagot dito class ay 27.5661 Newton. Okay, kapag kinonvert mo yan into kilonewton, divide mo lang by 1,000. So, ito yung kakalabasan. Ayan, ngayon class, take note, ito ay weight nung sand to fill the hole at saka cone. Class, yung kailangan lang natin is yung weight nung sand, ito, yung kailangan natin na to, yun class ay weight lang nung sand to fill the hole. No? So, kailangan natin dito class isubtract yung weight nung sand na nandun sa cone. Okay, so ito yon, kaya ganito yung formula natin. Ha, itong W sub 5 minus W sub C, yan yung weight nung soil solid nung sand. Okay, so class, kailangan pa natin isubtract dito yung yung weight nung sand na nasa cone. So dito class, given din na yung calibrated mass daw ng 1,000 to fill the cone ay 0.545 kg. So isusubtract natin ito dito. No? Pero kailangan muna natin to gawing kilonewton din ha para masubtract natin. Okay. So, class, ito yon, no? 0.545 multiply natin by 9.81 para maging newton, then divide natin by 1,000 para maging kilonewton. So, ito na class, meron tayong W sub 5 at saka W sub C. Ngayon, para dito sa gamma dry nung Ottawa sand, convert natin class ito, yung dry density. So, yung given class na dry density dry density ay 1,570. So kapag kinonvert natin yan class sa dry unit weight, so yan ay 1,570 lang times 9.81. Tapos divide mo by ito yung kakalabasan nun, 15,401.7 Newton per meter cube. Ngayon divide mo yun by 1,000 para maging kilonewton. So, yan ay magiging 15.4017 kilonewton per meter cube. Ngayon, yan na class, kompleto na yung mga kailangan natin para dito sa formula na to. Okay, so mag-solve natin itong volume na kailangan natin, no? So, substitute lang natin class yung mga values para dun sa W sub 5, yan ay 0.0275661 kilonewton. Minus yung W sub C, 0.005344645 kilonewton over 15.4017 no, kilonewton per meter cube. So, pindutin mo yan sa calculator class. Check natin kung tama ba. 534,645,15.40. So, yung lalabas class ay ilan ka? 0.00144427 meter cube or 1.4427 times 10 raised to negative 3 no, meter cube. Okay, so yan na class yung kailangan natin na volume. So itong volume na to class, ulitin ko ha, ito yung volume ng Ottawa sand na nag-fill dun sa hole. So yung volume na yan, equal din siya sa volume ng hole, and yung volume ng hole, equal din siya dun sa volume ng in-excavate natin na soil. So itong volume na to class, at saka yung nakuha natin na W sub 3, yan yung kailangan natin para dito sa formula na to. Okay, tuloy natin sa next slide. Alright, so pwede na natin class ma-solve yung gamma dry field. Yan class ay equal sa weight nung dry soil over the total volume. So ito na yung mga values natin class. 0.026769 kilonewton over 0.00144427 meter cube. So, input mo class sa calculator. Tingnan natin kung ano yung lalabas. 0.001. Ayan. So, class, ang lalabas ay 18.55 kilonewton per meter cube. So, yan na, class, yung hinanap natin sa letter A. Now, for letter B, kailangan nating i-determine yung relative compaction in the field. So, class, sa relative compaction, so yung kailangan natin sa formula is yung gamma dry field, tapos yung gamma dry max lab. So, itong gamma dry field, okay na ito, na-determine na natin, ito na yung value niya. So, kailangan natin ngayon, class, i-determine yung gamma dry max lab. So, para ma-determine natin yung gamma dry max na yan from laboratory, so, meron tayo, class, given na result ng laboratory compaction test. So, ipa-plot natin yun, class. Ito yun. Ipa-plot natin siya, class. Okay, so let's say for 6 na moisture content. So, dito sa x-axis yung moisture content ha, tas yung y-axis para sa dry unit weight. So, yung 6, corresponding dry unit weight niya ay 14.80. So, yung point na yon ay approximately nandito. And then, para sa moisture content na 8, no, approximately, or yung dry unit weight niya ay 17.45. So, approximately nandito siya, no. And then, para sa 9, 18.52, approximately nandito yan. And then, yung 11, approximately yung 18.9 nandito. Okay, and then 12, ito yon, yung dry unit weight niya, 18.5. So, bumaba na siya dito. Okay, and then 14 na water content, 16.9 na dry unit weight. So, nandito siya banda. So, yung mga points na yan, class, ay i-connect natin. And then, meron tayong ma-form dito, class, na curve. Okay, so from the curve, class, no, tingnan mo kung nasan yung, kumbaga na pinaka-peak niya na point, pinaka-mataas na point. So, nandito, class, yung highest point niya, no, banda dito. So, approximately, class, kung ipoproject natin yan papunta dun sa y-axis, no, para dun sa gamma dry. Okay, so approximately, class, yung value ng gamma dry natin ay nasa 19 kilonewton per meter cube. So, ito, class, ay nakuha lang natin by estimation, ha, itong value ng maximum dry unit weight na to. So, yan na, class, yung hinahanap natin na gamma dry max, no? Ayan. So, yan yung kailangan natin para dito. Okay, so yan, class, ay approximately 19 kilonewton per meter cube. So, therefore, pwede nating ma-solve, class, yung relative compaction. Okay, so yan, class, ay gamma dry field, which is 18.55 over gamma dry max taken from the laboratory, yan, class, ay 19. No, so times 100 yan, so i-compute natin 18.55 divided by 19, yan, class, ay 97.6%. So yan na, class, yung sagot, no, para sa letter B. Yan na yung relative compaction. And yan, class, ay actually greater than dun sa usual na percentage, di ba, for relative compaction na 90 to 95. So, ibig sabihin, okay yan, class. Okay yung value ng relative compaction na ito. Okay. Alright, for sample problem number 2, the following data were obtained from a field density test on a compacted field of sandy clay. Laboratory moisture density test on the fill material indicated a maximum dry density of 1,924.8 kg per meter cube at an optimum water content of 11%. So, meron tayong mga given dito, class, na weight ng moist soil removed from test hole, 1,038 grams. Weight ng soil after oven drying, that is 914 grams. And then we also have here volume of test hole from rubber balloon apparatus. Ito, class, ay 0.000479 meter cube. So, from this data, class, we're going to determine the water content. We're going to determine the dry unit weight of soil, and then we're going to determine the percent compaction of the field. Okay, so dito, class, sa may problem natin, ibinigay na dito yung maximum dry density, no, taken from the laboratory. So, ito na yung maximum dry density ng soil natin. Tapos yung corresponding optimum water content niya, ito yung 11%, no? Tapos ito naman, class, mga data na ibinigay dito. Class, ito ay para dun sa field density test, no? Ito ay para sa field density test or field unit weight test, no? So dito, from the given, no, we can say na yung ginamit na method dito, class, ay rubber balloon method, no? Since meron dito, class, given na rubber balloon or volume ng test hole from the rubber balloon apparatus, no? Okay. So, class, for this problem, yung una nating i-determine is yung water content dito, class, sa from this data. Okay, so yung water content, class, nung soil na in-excavate natin, no, from the hole. Yan yung tinatanong na water content. Okay, so para ma-determine natin yan, no, meron naman tayo dito class mass or weight nung moist soil, tas yung mass nung oven-dried na soil. No? So, sa pagkuha natin ng water content, di ba, it's just weight nung water or mass nung water over mass nung soil solid natin, which is just equal dun sa, yung formula na yun, equal din siya sa mass nung moist soil minus mass nung dry soil over mass nung dry soil. Tama? So, pwede nating malaman directly yung water content. So, yung mass nung moist soil natin ay 1,038 grams. Yung mass nung dry soil natin, 914 grams. And then, mass ng dry soil, 914 grams. So, from here, class, ang lalabas dito, class, ay 0.1357. So, times natin by 100 para maging percent. Ito, class, ay 13.57%. So, yun na yung water content na hinahanap natin for letter A. Now, for letter B, yung dry unit weight daw, class, nung soil. So, para sa dry unit weight nung soil, ang kailangan natin dito ay weight nung dry soil over the total volume. So, in this case, class, yung weight nung dry soil, given na siya, or mass, no? So, ito ay mass. So, i-convert na lang natin into weight ito. Okay, so ito ay nasa grams. Okay, over the total volume. So, yung volume dito, class, given na din, kasi binigay na dito directly na yung volume daw nung test hole. Yung volume na yun ng test hole from the rubber balloon apparatus, equal din yun sa volume mismo nung soil na in-excavate natin from that hole, which is yun yung kailangan natin, no? Okay, so yan ay 0.00479 meter cube. So, dito class, para dun sa weight nung dry soil, convert lang natin to class into kilonewton, no? So, convert muna natin into kilogram. So, ito ay divided by 1,000 kasi grams to eh. Para maging kilogram, divide by 1,000, ang mangyayari, 0.914 kilogram. Tapos, multiply natin by 9.81, magiging newton. Divide natin by 1,000, magiging kilonewton. So, yung lalabas dito, class, ay 0.008966 kilonewton. So, ito na yung weight ng dry soil natin na kailangan dito. Tapos, yung total volume, yan na to. Ito na yun. Okay. So, substitute lang natin. Ito ay 0.008966 kilonewton over the volume, which is 0.00479 meter cube. So, yung lalabas dito, class, ay, check natin sa calculator, 8966 over 479. Ang lalabas, class, ay 18.72 kilonewton per meter cube. So, yan na yung hinahanap natin na dry unit weight ng soil, ha? So, yan ay yung dry unit weight nung compacted na soil. Okay, so yan, class, ay sagot na for letter B. Now, for letter C, pinapadetermine sa atin dito, class, yung percent nung compaction nung field. So, para dun sa percent nung compaction or relative compaction ito, class, no, yung gamma dry field, ito na yon. Tapos yung gamma dry max, class, pwede natin yan makuha dito sa given class. No, yung given dito ay maximum dry density. So, convert lang natin itong density na to into dry unit, or itong dry density na to, convert natin into dry unit weight. So, convert lang natin. So, yan, class, ay 19.24 or 1,924.8 kg per meter cube. Multiply natin by 9.81, magiging newton per meter cube. Then, divide natin by 1,000 para maging kilonewton per meter cube. Ang lalabas dito, class, ay 18.88. So, double check nga natin, class. Times 9.81 over 1,000. Yan, 18.88. Okay, so yan yung kailangan natin na gamma dry max for our formula. So, substitute na natin, class. Yung gamma dry field ay 18.72, ang gamma dry max ay 18.88. So, yung lalabas, class, dito na relative compaction, times mo to by 100, ha, para maging percent. So, ang lalabas ay, ayan, 0.9915. So, multiplied by 100, magiging 99.15%. So, ito na, class, yung hinahanap na percent compaction or relative compaction nung field natin. Okay. That ends our discussion for this topic. I hope that you learned. See you again sa next video discussion natin, class. See you. Bye-bye. Araw mabuti. God bless.